Okay, let's go ahead and solve for the output Y of this complex circuit, where the inputs to the circuit are A and B, where A and B can be 0 volts, 1 volts, or 5 volts, where if it's 0 volts, we give it a digital value of 0, and if it's 1 or 5 volts, we give it a digital value of 1. And as you can see in this circuit, we have essentially two PMOSs connected in series and two NMOSs connected in parallel, where if we have a 0 going into the inputs of our PMOS, we say that it is on, and if we have a 1 going to those inputs, we say that it's off. And vice versa, if we have a 1 going into our inputs for our NMOS, we say that it is on, and if we have a 0 going into the inputs of our NMOS, we say that it is off. So then the first condition we want to consider is when A is 0 and B is also 0. So if A is 0 and B is 0, this means that both my PMOSs are going to be on because their inputs are 0, and both my NMOSs are going to be off because their inputs are 0. As a result, Y only sees VDD, which is equated to a digital value of 1. So then the next condition is when A is equated to 0 and B is equated to 1. In this case, A is 0, B is 1. This PMOS here is on. This PMOS here is off. This NMOS here is off, and this NMOS here is on. As a result, Y only sees ground because when he looks up, there's an open circuit at M3. So then Y is going to be a digital value of 0. So then my second to last condition is when A is 1 and B is 0. So then if I consider A is 1 and B is 0, this PMOS here is going to be off. This PMOS here is going to be on because its input is 0. This NMOS here is going to be on because its input is 1. And this NMOS here is going to be off because its input is 0. As a result, Y sees ground over here. But if it looks up, this M4 is open, so it does not see VDD. And so that means that Y is equated to a digital value of 0. So then our last condition is when A is equated to 1 and B is also equated to 1. So if A is 1 and B is 1, both my PMOSs are off and both my NMOSs are going to be on. As a result, Y only sees ground, which then equates Y to 0. So then we can say then that Y is equated to A plus B inverted, or we can call this a NOR gate or an inverted OR gate, where essentially this circuit here is the transistor level implementation of the NOR gate. Thank you.